This clip we're going to look at using ratio in scale drawings or maps, and it's used in a slightly different way. So if we've got a given scale of 1 to 200, what that means is you can use any measuring scale you wish. You can be working in inches or centimeters or millimeters, it doesn't matter, because one of whatever unit you're measuring on the map is 200 times bigger in the same unit in real life. So if you've measured a wall 5 centimeters on scale drawing, it'll be 200 times bigger in real life. So it'll be 5 times 200, which is 1,000 centimeters in real life. Now, we wouldn't tend to measure walls in centimeters in real life. We measure it in meters. So to turn that into a more sensible unit for its size, we would divide it by 100 centimeters in a meter. So when you divide by 100, you end up with 10 meters. And that's pretty much how we work with ratio scales. You multiply them up in the given units and then turn them into more sensible units. So usually we'll be working with turning kilometers into meters, meters into centimeters, or the other direction. So the common equivalences that you need to remember is there are 100 centimeters in a meter and 1,000 meters in a kilometer. So if we need to shrink from real life onto the scale drawing, say 7 meters, first of all we would turn it into centimeters, and then what we've got is our map ratio of 1 to 200, and we want to work out so if it's 700 in real life, how big is it on the page? So we work out what the multiplier is by doing 700 divided by 200, which is 3.5. So lots of 3.5 gives us how long that would be, that 7 meter wall would be on the scale drawing. So here's a past paper question. The map below shows the route from Edinburgh to Dundee. The route from Edinburgh to Dundee is approximately 4 centimeters on the map. The actual journey is approximately 100 kilometers. Calculate the scale on the map given your answer in the form 1 to something. So we've got 4 centimeters is equivalent to 100 kilometers. Now we can't turn it into a 1 to something until the units are the same both on the page and in real life. So I need to change this 100 kilometers into centimeters. So I know there are 1,000 meters in a kilometer, so that 4 centimeters is equivalent to 100 times 1,000 meters. Centimeters and meters, they're still not the same. I know there are 100 centimeters in a meter, so that means my 4 centimeters is equivalent to that, which is 10 million centimeters. Now I've got them both in centimeters. I've got it as a map scale. The only difference is now I need to have it as 1 to something. So to get this to 1, I have to divide by 4, which means I have to divide this by 4 as well. So I've got 2, 4, 6, 7 zeros divided by 4 is 2, 5 followed by 5 zeros. So 2,500,000. So the map scale is 1 to 2,500,000. So you need to have the same units on each side of the ratio. So let's take a look at another past paper example. Cheryl and Ben planned a cycle ride using a 1 to 25,000 scale map. The route they planned measured approximately 80 centimeters on the map. Calculate approximately how far they planned to cycle. You must give your answer in kilometers. So we've got a 1 to 25,000, 80 centimeters on the map will be 80 times as big in real life. So we've got to do 25,000 times 80 is 2 followed by 1, 2, 3, 4, 5, 6, 2 million centimeters in real life. I need to give it in kilometers, so if I divide it by 100 it'll turn it into meters. So that'll be 20,000 meters, which I'll divide by 1,000 to turn it into kilometers. So it's a 20 kilometer cycle. After the ride, Cheryl's cycle computer showed she travelled 24 kilometers. What was this measurement on the map in centimeters? So now we're going the other way. I've got to take my 24 kilometers, times it by 1,000 to turn it into meters, times it by 100 to turn it into centimeters. So 24 times 1,000 times 100, so that's 24 followed by 5 zeros centimeters. And then using this scale, so I've got 1 to 25,000, I want to work out how big it is on the map when it's 2,400,000, 1, 2, 3, 4, 5 in real life. So I need to know what the scaling up is, and I get that by doing 2,400,000 divided by 25,000, 96 centimeters. And that looks sensible to me because I know here that 20 kilometers was 80 centimeters. So 24 kilometers is going to be a bit bigger, which it is 96 centimeters. So I'm fairly confident that I've done that correctly. Part C. Ben and Cheryl's cycle computers showed 24 kilometers after the ride. The ratio of the distance Ben cycled to the distance he pushed his bike uphill was 5 to 1. The ratio of the distance Cheryl cycled to the distance she pushed her bike uphill was 11 to 1. Calculate how far Ben cycled and how far he pushed his bike uphill. So of this 24 kilometers, he pushed and cycled to a ratio of 5 to 1, so 6 parts altogether. So each part of the 24 kilometers is 4 kilometers. So he cycled 5 parts, so he cycled 20 kilometers, 5 lots of 4, and he pushed 1 part which is 4 kilometers. And then for Cheryl, who went in the ratio of 11 to 1, there's 12 parts. So 24 divided by 12 is 2 kilometers. So she cycled 11 twos are 22, and pushed 1, which is 2. Sorry, that's gone off the screen. So ratio of 11 to 1 is 12 equal parts, 24 kilometers divided by 12, so each part is 2 kilometers. 11 lots of 2 is 22, 1 lot of 2 is 2. So there you go. So that's ratio on maps and scale drawings.